Another question is integrating into large systems. We kind of did piecemeal conversations the whole time. What about these large systems that you're coming into? And I've got a couple questions. What stage is Tecweigh getting involved? Is it the original design on like a large scale system, or are you coming in after have engineers already put everything together? Where do you start getting involved?
I could comment on that part. Is that I work with a lot of different engineering firms. Usually, it would, if in speaking to the aggregate mining industry, that would primarily be around conveyors. The convey could be the engineering firm that is providing the conveying systems or the conveyor manufacturers. Usually, we are, provided that data on the conveyor, and then we uh, look at what's required for that application and quote the correct equipment. So, and then the other part to that would be to make sure that that gets installed correctly by whatever kind of engineering firm or contractor that is. And then the other side that again, I just mentioned what I was just talked about was the mechanical side. The other part would be the electrical side, which is to make certain it can communicate with their control system too as well. And there's different, sometimes one customer will be using one type of PLC, like an Allen Bradley, and another one a Siemens, and another one something else. So each of those have specific requirements to be able to communicate with the plant's control system. And as a supplier of equipment, we have to meet those communication capabilities too as well. So that's a challenge on maintaining, your products to the current level of connectivity.
And then, Mike, if you could just give us a quick snapshot of, well, it doesn't have to be quick, actually. We have time, but we could you give us some insight into specifically the maintenance of these large scale operations, the servicing of them?
To be 100% honest, the maintenance from a large scale versus a smaller scale doesn't really change.
Doesn't change.
It doesn't. There, it's mechanically and electrically, they're working the same way as the smaller ones. It just might be a bigger capacity load cell or a wider scale. So obviously with the the bigger equipment, obviously you have a larger area of problems that can occur, but it's the same types of things that occur.
Right.
So really, as far as the size, the maintenance aspect, I don't think really changes on that. Now if you say bigger in the size of scope of equipment that is involved,
Yeah.
then yeah, then you can get to peripherals that maybe you got to look into. But the nice thing about most peripherals is they're either when you're talking PLCs, especially for using like a field bus. So like Sheldon was talking about an Allen Bradley or a Siemens, if they're using an Ethernet connection, there's not a lot of maintenance that needs to be done with that.
Right.
Analog, if we're using an analog, so using an analog signal, the only maintenance that would be done to that is from time to time is you're going to want to check the scale on that. And what I mean by that is, on our analog signals, say you're doing a controller that has 0 to 100 tons per hour. So if we were using a 4 to 20 milliamp output, at 20 milliamps, you'd be showing 100 tons. Well, from time to time, you will probably want to make sure that's still accurate. So you are seeing that 20 milliamps at 100 tons, whether the end user say they had a card that went bad and now the resistance has shifted just a little bit.
Hmm.
That would be maybe a maintenance thing electrically to do. But as far as load cells, idlers, things like that, speed sensors, the size, the small ones, it's the same maintenance procedures as the big ones.